All right, hello everyone. Here I'm going to be going over the Quiz 2 study guide. So, going over this and going through all the practice problems. I'm recording this on Sunday night. So, I am proud that the New York Jets are now officially not the worst team in the NFL because we won a game. So, it has been a good day. And the Yankees also made the playoffs. So, great day. All right. This test is going to be taken on Friday. So that is the 8th. So how we're going to be doing this, and I'm going to announce this in class. Taking this quiz the 8th. We will not have school on Monday the 11th for Indigenous Peoples Day. The 12th is going to be a review of the entire chapter, and then the 13th and 14th, so during the lab periods, you will be taking the first unit test. So this is the quiz, all of this for quiz 2, and then the test will be on the following week. Um, so you're already, it should be relatively fresh in your mind, the stuff for quiz 2, for the test. So I'll be working on making that test and getting that all out for everyone. So you all should be seeing this. Um, Probably Tuesday night or Wednesday night. We'll see. I'm not sure yet. But you'll be seeing this video when I do post it to the Google Classroom. Without further ado, this is for quiz 2. So there is the quiz 1 study guide, and then there's going to be one or two more topics that we're going to have for the test. So basically everything that's here, everything that was in the first quiz, and then one or two extra topics that I just kind of need to throw in. All right. So here's the topics. These can be found in the units PowerPoints and the corresponding video that I posted to YouTube. So this was the PowerPoint that we saw the day that I was absent. And what I really want us to know from here is these different units and the different properties that they go with. And when I say property, that's basically what you're measuring. So, for example, time is one of those properties. You're measuring the time that something takes to happen or the length of something. That's the property. Um, so these are the ones that we're probably going to be knowing. Well, these ones, and then density is the other big one. We've spent the lab on that. Um, this week on Thursday and Friday, we're going to review um, the density equation as well as go over the lab that you should be handing um, in a few hours based off of the time that I'm recording this. So, we're going to go over that before the quiz. So, review before it. That way I'm not testing you on something that we haven't really reviewed. Um, so yeah, so these are the different properties and then the units that we will be using to measure. Um, so, these are the base units: seconds, meters, grams. And as we're going to see, we can manipulate this with the different prefixes, kilometers, centimeters, millimeters. Volume, we have two different ones. You should know the difference. How do we get to each one of them, right? Volume is a derived unit. We get it from length. We take length times width times height. And temperature for Kelvin, I'm probably gonna amend this just like literally right now, or I could type. Oh my God, I'm like struggling to type. Awesome. So we can use Kelvin or Celsius. We're gonna most likely use Celsius unless there's an example that explicitly calls for Kelvin. And I explained why, the same type of scale. Um, Basically, a 5-degree difference in the Celsius or Kelvin scale is the same amount of temperature difference compared to Fahrenheit, where 5 degrees is not as much of a difference. And we're going to go over temperature a lot. Don't worry, it's really just the introduction. Density, you should know this formula. You should know what each one of these letters stands for. I've given it to you in multiple, um, different media from like 2 or 3 different PowerPoints. Gave it to you on your lab, so you really should be knowing what this formula is. I will give you this formula. I will not give you what each of the letters stands for, right? So this thing right here, is the Greek letter rho. This is density. This m, this m, it's not letting me do that. The m up here is that is mass. It is not meters. We're talking about the different properties here, right? So V stands for volume. So when we're talking about volume, we know we're talking about the properties. We're talking about the first things here. Let me yeah, let's do this. We're talking about these things, right? We're not talking about the different units. We're not talking about meters. We're talking about mass um, in this example. So, let's see. Okay. So this is mass over volume. So you would take the mass of something divided by the volume. That's how you get your density, right? So a very, very basic example. If you had a mass of 5 grams and you had a volume of 2 milliliters, your density equals 5 grams over 2 milliliters. And then this is a division sign. So you would run this in a calculator. 5 divided by 2. So 2.5 grams per milliliter. And this slash here is the same as, like, this slash is really the same as a division sign. Um, it's just a lot easier, especially if you were typing this out. Like, if you were typing this out, as I can probably show here, right? Like, grams per milliliter. A lot easier to do that. To actually, like, get one of these, like, division bars, you have to do a whole bunch of stuff to get it. So that's why we can do the slash, or we can do the bar like that. So you should know what each of these letters stand for, right? So these are like the shorthands. So when I say seconds, right, it should be sec, SEC, or S. Either one does work. It's fine, whichever one you want to use. It's technically I think it's S, but because SEC, a lot of the other time ones are 3 letters, 3 to 2 letters, so that's why you can use SEC. Either one works. I don't care for that one. But meters is M, grams is G. Cubic meters, what that means, meters to the 3rd power, and liters. And then Kelvin is a capital K. And I'm also going to just write in Celsius here. Yes, and here we can go. Yeah, it's annoying, but we have to go to degrees Celsius. Yeah, so these are the symbols that we should be knowing, what they stand for. Because I will be using them regularly. I will be writing out, 5M, and you should know that that means 5 meters, or 5G, that is 5 grams. Um, and I will also say here, just a quick reminder, if you go to the units PowerPoint, I talk about this, but the capitalization matters. So I'm going to say that just now. Where's my pen? See, save mouse. Right. So the difference between G and G, these are two exact like different things. They're not the same. I don't know why I crossed this one out. So this is a gram, this is not a gram. All right. The capitalization does matter. MM is a millimeter. Capital MM is a megameter. That's like 1 times 10 to the 6th meters, or that's a million meters. So it really does make a difference. This is 1,000th of a meter, and this is a million meters. So there's a big difference there, just by having it capitalized. So these prefixes, I'm gonna scroll down. This is probably the extent of what you really need to memorize. I mean, you should be knowing these as well. Um, but this you need to memorize. Like that's the extent. Any other like Any of the of the prefixes that we might possibly use, I would tell you about when the time comes, and I would, give that to you. I'm not expecting you to memorize them, but kilo, milli, and centi, you should know. Um, and these are the conversion factors here, right? So 1,000 milligrams equals 1 gram. I mean, mil, if you think of words like millennium is 1,000 years. Um, I know in Spanish, 1 mil is, un mil is 1,000. So like that Latin roots, that's where it comes from. Spanish being a romantic language. Same with centi. Like I think in Spanish, it's ciento is 100. That's where we get the term century from. So 100 centigrams is 1 gram. 1,000 milligrams is 1 gram, and then kilo also means like 1,000. I don't know where that comes from, the word usage. Sorry about that, but 1,000 of the grams makes a kilogram. So milli and centi are smaller compared to just the base unit, and then kilo is 1,000 times more than that. So you're gonna have to know these. We're gonna be using these all throughout the class, so you definitely need to know these. Okay. All right. All right. So the density lab. So if you are watching this on Wednesday when I post this, we will not have gone over the density lab in class. We are going to, I promise. Um, this gives me some time to give you all some feedback, but also we're going to do it in lab, just going over it. Um, so what I want us to know is how to calculate the density of someone given the same measurements that we took in class, right? So if you remember in class, we took um, we took measurements of the metal and of water, trying to figure out that density. So with the metal, and you'll see this when we get to the practice problems, basically what I mean is, okay, we took the length, the width, and the height of the metal. You can use that information to calculate the volume, and then you also took the mass. So with that information, you can calculate the density. We also took an example, we took the graduated cylinder, we got the volume of it, put in the metal, we saw the volume go up, and then we can use that volume to also calculate the density. So knowing how to do those two steps, that's what I mean by this, is calculating the density of this unknown metal. And again, here's the formula. You're going to need to know this. Um, and you should also understand how to manipulate the above formula. So what I mean by this is if I give you two of these variables, you should be able to figure out what the third variable is. And I'll just do an example here about how we do this, because I don't think I've explicitly gone over this. I'm going to do it now. I will also go over this on Thursday or Wednesday, depending on when we have lab. So if our formula is density equals mass over volume, and if we go back to that example that I have, let's say our density was 2.5 grams per milliliter, and I gave you the mass of something was, let's say it was 10 grams. With this information, you can algebraically solve for the volume. So how you do this, this volume right here is a unit, right? This is a variable. So we have to isolate this volume to give us our unit. So I'm going to go scroll it down a little bit. Okay. So, you multiply by the volume on each side, like so. So this volume is on top, and this is kind of like the dimensional analysis that we've done. We get this over here, this cancels out, and we are now with the volume times 2.5 grams per milliliter equals 10 grams. Now to get rid of this whole thing, right, again, you divide by 1 over 2.5. So you're dividing by the inverse of it. So 2.5 on top, you put 2.5 on bottom. This grams is on top. This milliliters, so this grams goes over here. This milliliters goes up here. So I'm just going to put the milliliters on the top now. And this is what you multiply by. So you see how this is the inverse of this? They are opposites. And you could probably solve this a different way. I'm just going to give you the full example. And then you multiply by this same thing times milliliters over 2.5 grams. And just keep going, scrolling down. We're now left with, so this cancels out. 2.5 grams cancels out. 2.5 grams cancels out. Milliliters cancels out. Milliliters cancels out. Over here, we're just left with the volume equals, we take 10 divided by 2.5 is 4. This gram cancels, this gram cancels. We are left with 4 milliliters. And there we go. So I went the very algebraic route, really showing my work. For this type of experiment, and I will say this, if I ask you a question like this, like back up here, you don't have to show me everything here, but you need to set up the formula. So if I ask you this question, right? All right, density equals 2.5 grams per milliliter, and I said the mass equals 10 grams. I don't need to see your entire algebraic thought process. I think that's a little bit like excess, but I would need to see you do like 2.5 grams per milliliter equals 10 grams over V, right? If you did this and then you did the algebra, that's fine. But I need to see at least this. I don't want you to just write 4 milliliters. If you write 4 milliliters, you will lose the point. I'm telling you all that right now. All right? Okay. So let me get back to where I was. Dimensional analysis. So this was the basically converting units, and there's going to be some trickier ones. The best example is how to convert pretty much anything. Um, so, for example, we saw, Sydney McLaughlin ran the 400 meter hurdles in 54.36, I believe it was, seconds, and we converted that time into miles per hour. That's the type of question that you're probably going to see on your quiz and on your test. Um, so know how to do that. And we're going to be spending Tuesday, going over this in class. There's going to be a practice problem that I'm going to be going over later. That's the same type of thing. And as you've seen, and I'll probably explain in class, I like to break it down into the steps. Really, just like that scaffold, building up to it, rather than just saying convert 400 meters per second into miles per hour. I like to break it down, especially when we're new to this. This is not true for the honors kids. I expect you to be able to do it on a quiz or exam. In our practice, we're going to be breaking it down, but on a quiz or exam, you will not get that same level of scaffolding. Okay, so finally, this is for the scholars and honors kids. We went over scientific notation. You should know, and this is pretty simple. The examples are going to be very simple. Convert from standard notation, which is normal numbers, to scientific notation and back. So going from scientific notation to normal standard notation. So you're going to see this. You should be able to do a conversion for a positive and a negative exponent, also known as a number greater than 1 and a number less than 1. So like literally this is that simple. This is just something that you can use to recognize when we are going to see scientific notation throughout this year and be using it a lot, right? I'm not going to throw you any of those tricky ones like the 7.28. That's, this is used for big and small numbers. So something like this is what you're going to see. Something like just like this, how to get the standard notation, scientific notation. All right. So let's get into these practice problems. And when I mean, the quiz is going to be similar to this. It will not be exactly the same. It's going to be similar to this. The test will not be. I don't. I think the tests should be that extra step. The quizzes are kind of like the basics, um, relatively basic stuff, and then the test is really taking that information and then building up on it. That's why I'm giving you. We're having our test during a lab block. You have that whole time to do it. Um, so this is basically really just, do you know these different things? Give me appropriate metric units, right? So length, meters. You can really just write m. That's what a meter is, right? You can type it out. You could give me kilometers. Don't care. Anything that is appropriate metric units. Do not give me inches. Do not give me yards, feet, miles. We're using metric units. All right, so kilometers, or meters, or centimeters, or megameters if you really wanted to, right? So mass, we measure mass with the scale, grams, or G, on my spacebar, G, right? Or kg, anything like that. Really just, what are these, how do we measure these different things? Temperature, K, or Kelvin, or Celsius, or it's actually degrees Celsius. It's not degrees Kelvin, it's just Kelvin. It's annoying, it's weird. I won't penalize you if you say degrees Kelvin. But anything like this. Volume. So for volume, you can give me liters or milliliters. Um, but you can also give me, cubic meters or, centimeters. It's annoying that I have to do this, right? Centimeters cubed, like that. You can give me any of that stuff. All right. Density. So if we have, or you should be knowing, mass over volume. Another way to remember this, actually, this formula, now that I have it on my mind, this makes a heart. So if you take a heart like this and you cut it in half, your formula is mass over volume, right? Mass over volume. This equals density. So it's a broken heart. But so, this one you need to give me, right? The units of mass is grams divided by volume. We literally just did that. Grams per liter. Grams per milliliter. Oops. Grams per cubic centimeter. I don't feel like getting the little 3 exponent again. Anything like that works. But you should know that it is a derived unit. We get the unit from other units. And time, anything here, seconds, minutes, days, um, hours, years. If you give me centuries, go for it. Not light years. Light years are a distance. Do not give me light years. All right. Number 2, right? So this is the symbols. So again, I use these shorthands. This is why you need to know those symbols. You need to know the symbols for what the prefixes are. That didn't, okay. Right? So kilogram, that K for the kilo, it's K. Grams are G, kilograms. Make sure that they are both lowercase. If you give me the wrong capitalization, I'll take off half a point. All right? It does matter. Do not give me a capital K or a capital G in this instance. So milliliter, milli, lowercase m, liter, capital L. Centimeter, again, centi is a lowercase c, meter, lowercase m. Cubic meters. So when we say cubic, that is to the third power. So we have meters to our third power. So you could give me, if you were typing this out, which you'll be handwriting your quiz, but if you wanted to do this, you can press Shift and 6 and give me a little caret thing. You could give me that. You could give me, I'm just going to copy and paste it. Give me that. Don't care. Works fine. A centisecond. This is, we don't use it, but it's technically, you can do this. So centi is C, and the second is S, or use. We could do that as well. CSEC. It's fine. I said you could use either. a centisecond, right? If you had a clock, right, and you had a 1/100th of a second, that's what a centisecond is. 100th of a second. All right, so here's the talk. This is the all right, we have all this here. Oops, not should not be any points there. Um, Here is an example. So this was a student. They did the same experiment that we did, that density lab. They took the mass of a metal. They took its length, its width, and its height in centimeters. So calculate the volume of the metal using the above data. Make sure to include your units. So the units are in this data. This mass was calculated in grams. These lengths were given in centimeters. So calculating the volume with 3 length times width times height. So how am I gonna do this? All right, I'm gonna try something, and we're gonna see if this works. 'Cause I want to keep this study guide, with answers. So let's see if this works. All right. So volume, we know that it is the length times the width times the height, right? So this is going to equal 3.2 centimeters times 2.2 centimeters times 1.8 centimeters equals. So I'm gonna pull up a calculator. I don't think you can see it, unfortunately. Um, so I'm just gonna do this on a calculator, and you will have a calculator for the quiz. I really should have mentioned that. 3.2 times 2.2 times 1.8 gives us 12.67 equals 12.67. Now our units, very important. We have a centimeter times a centimeter times a centimeter. If you replace the centimeter with x times x, that gives you x to the third. So your unit should be centimeters to the third, and you're done. All right, so I'm going to see if I can like copy and paste this into here. Let's see if this works. Awesome, we got it in. Okay. Basically, I'm like taking a screen cap of this thing and then just copy and pasting it in. Nope. All right, let's get rid of all this stuff. Okay, there we go. Perfect. Awesome. So you should be able to, you will see this when you open up the answer key for this. All right, so with this information, calculate the density of the metal, includes your units. So here's our density formula. Density equals mass over volume. So we have our mass. I'm gonna get my pen out. Our mass is right here. We got this from our data sheet. So this person, they put the metal on the scale. This is what they got. So if rho, or density, equals 22.44 grams, we know what our volume is. Our volume, 12.67 centimeters cubed. And you can use a calculator to solve this, which I'm going to do off screen. So this is a division sign, right? You have two numbers on top, you divide it, and you get 1.77. Now, what are our units? Our unit is grams on top, centimeters cubed on the bottom. So there is our units. What I'm going to do here is copy this and put this calculation in here. So, we're going to just put this onto the next page, question mark. Yeah, we fit it. There we go. Right, so there you go. There's your density, 1.77 grams per centimeters cubed. Now, okay, here, if you had 100 centimeters worth of this metal, what would its mass be? If you had a cube and its volume was 100 centimeters cubed, what would its mass be? So this was the whole thing I was talking about up here, right? You should understand how to manipulate the above formula, this type of stuff. That's what we're doing down here. Let's get to it. So our density, I'm going to show us how to do this. All right, so we go back to our formula, 1.77 grams per centimeter cubed. We go to our formula, equals. We don't know what the mass is, so I'm going to use X as our mass, or actually, you know what? I'm going to use M just for a mass, just to show consistency. Mass over our volume is 100 centimeters cubed, right? So what we're going to do here we're going to isolate our mass. This is the variable that we need. We're going to multiply each side by 100 centimeters cubed. So you can take 100, multiply it by 177, 1.77, that will give you 177. This centimeter cube is on top. It's like right here. It's kind of hard to see. Cancels this out. You get 1.77 times 100 equals 177 grams. This cancels out here, equals our mass. So our mass is going to be 177 grams. So let me take a picture of this. Oh, let's get a little bit better. Oh. Right, so there is our answer. And this is a lot of the dimensional analysis that we've been doing. All right, let's see. There we go. Okay, convert your answer from part C. Convert your answer to part C from grams to kilograms. So our answer was 177 grams. So I'm going to clear us out and go back. So if we scroll back up, I gave you this conversion. Why are we not? Right? 1,000 grams equals 1 kilogram. I will not give you this. You must know this one for the quiz and for the test, all right? So let's get back to this. So with that being said, 1,000 grams equals 1 kilogram. We have 177 grams, and we're going to multiply by our ratio up here. We're going to make the grams go on the bottom, so it'll cancel itself out, times 1 kilogram. We're going to multiply through, so I'm going to give like arrows. This is kind of where I am going. So we're going to do 177 times 1 over 1,000 equals, or let's not equals. We have grams times kilograms over grams. So these grams cancel each other out. 177 divided by 1,000 is 0.177. So this goes to 0.177 kilograms. Now, same with this one. I don't need every single thing here, right? I want you to show this. I want you to show and set up this. That's the bare minimum. If this helps you, like if this stuff like here, if this helps you, Oh, that's weird. Classic. All right, clicks. This stuff. If this stuff helps you to solve it, then write it down. I'm really going over and up and beyond so that if this is the first time you've done this, you have the full way to do it, okay? So if you just give me this and first let me I want to get this answer in. I want to get this answer like copied and such. So awesome. I'm gonna put this right here. Okay, there we go. Perfect. So that's gonna be, I need to put like an arrow. That's what I should put. Insert. Can I do that? That's fine. This arrow here. There we go. Right, so you know that that's the answer to it. All right. Okay. So as to what your work would need to be at a minimum, I'm gonna get back to this. Right. If you give me this, 1,000 grams equals 1 kilogram, you line it up like this, and then I want you to physically cross out the units like this. You can skip this step here. You don't have to write out all of this. I'm just showing this as an example, but you can just cross out your units and then, give me 0.177. All right, I don't need you to write out all this stuff. I want you to cross out the units because if we're doing multiple units, you need to keep track of your units. So I want you to cross out the units. If you're doing you can, and we're learning this when we do through stoichiometry. You can cross out multiple things. You can line up a lot of things at once, but you just got to keep track of your units, right? Cross out the grams. Cross out the grams. You know that those are not part of your answer. All right. So let's move on. All right. Last two questions. You buy a car in Canada and its fuel efficiency is given to you as 15 kilometers per liter. So again, that means that the car will go 15 kilometers for every 1 liter of gas. And I asked you to convert this to miles per gallon. So if you buy a car or in an international place, their fuel efficiency is probably going to be different. It's not going to be in miles per gallon. So for example, my car gets about 30 miles per gallon. That's, I don't know what that is in kilometers per liter because I know miles per gallon. I know that 30 miles per gallon is pretty good, especially for a midsize car like I got. Um, so how we do this, and I broke this down, and we're gonna go over this on Tuesday. For all my classes, we're gonna break this down. The first thing is we're going to convert the kilometers into miles, right? Kilometers is used for length. Miles are used for length. Because they are both length, that's why we can do that conversion. Liters and gallons are both volume, so we can do that conversion. So 15 kilometers to miles. So let's start off. Here is our 15 kilometers. That's what we're trying to convert. And I will give you this ratio. The only things I'm going to have you remember are those things I talked about earlier, right? I will give you any type of conversion that's not base 10. That's not metric prefixes. So we have 15 kilometers. Our ratio is 1 kilometer to 0.62 miles. Right, so I'm going to do the oversimplification here, but you can cross out this kilometers and this kilometers here. I'm going to show you, just to write it out. So 15 times 0.62 over 1. Our units are kilometers times miles over kilometers. The kilometers cancel out. 15 times 6 point or 0.62 equals 9.3. So we're left with 9.3 miles. So 15 kilometers is 9.3 miles. I'm going to put this in. I really should be doing this so it's horizontal, but it's fine. Do it for the next one. So now we have to convert 1 liter. So what I said, this car will go 15 kilometers for 1 liter of gas. So we're dealing with 1 liter of gas. This is an easier example than the 54.36 seconds that we saw in the Olympic hurdles example. So I'm still going to write this out. 1 liter times 3.78 liters, 1 gallon. Here's our conversion. I'll write it over here times time. 1 times 1 liter times gallon over 3.78 liters. Liters cancel out. We have 1 divided by 3.78. That's what we end up with. 1 divided by 3.78 is 0.265 gallons after we simplify that. So let's put this answer in here. Okay. Perfect. Okay. So what is the miles per gallon of this car, right? What is the fuel efficiency of this car? So how many miles are there per 1 gallon? So easiest way to do this, right? Our formula for fuel efficiency, right? We have miles per gallon, right? So the fuel efficiency, I'm just going to use FE, is going to be, right? We say it's in miles per gallon. Miles per gallon. We have a miles. We have a gallon. Let's do that right there. So our miles is 9.3. Our gallons is 0.265. I can write over here. We're squeezed in. Right? Again, take this to the calculator. This is division sign. 9.3 divided by 0.265. Write that in. Calculate that. 35. I'm just going to take, we'll take 2 decimal places for this. 35.09 miles per gallon. So this is a pretty good car, right? Some good fuel efficiency there. I know a lot of you are starting driver's ed, so you'll start to learn when you have to pay for gas, how much fuel efficiency matters. If you go more miles on more gallon, you don't have to spend as much money on gas. So I'm gonna introduce this here. So this car's got pretty good gas mileage. We like that. All right. So if you are from my regular classes, this is a good place to stop because what we're going to be doing now is scientific notation, which we only went over this in Scholars and Honors. All right. So without further ado, and like I said, literally one big number, one small number, one big number, one small number. All right. Making this as simple as possible. I'm not trying to trick you on these, and I won't. I'm not gonna have that stuff. Not trying to trick you on this. All right. So here we have, yeah, here we go. So let me clear everything. So we have 8,123,333. So first, I'm just gonna write this out a little bit bigger for my answer. I'm probably gonna end up posting them below just because I can. So first we count how many digits there are from the first digit to the decimal place. So there's a decimal place right here. I don't show it, but it is there. So we have, well, 1, 2, 3, 4, 5, 6. We have 6 digits after that first 8. All right. So then we take the first digit, that's our 8, draw a decimal place after it, and then we take the next 3 digits. 8.123. Multiply this by 10. Bring the 6 down. 10 to the 6th. And you're done. So let's put this down here. Okay, that's example 1. Example 2. We have 0 point, how many zeros are there? 1, 2, 3, 4, 5. 1, 2, 4, 5. 0 0.1, 2, 3, 4, 5, 7, 8, 6. All right, so first we count the amount of zeros after the decimal place. 1, 2, 3, 4, 5. You add 1 to it. You get 6. Make sure to add that 1 when you're dealing with smaller than 1 numbers, all right? You take the first number, you write 7, 8, 6. Put your decimal place there. We have 7.86. Take that first digit, put a decimal place after it. Your number, right? The first number should be between 1 and 9.9. It should be a single digit, 8.123. It's within 1 and 9.9. 7.86. All right? Multiply it by 10. You take this number, you make it negative. Don't forget that negative. All right? If you forget that negative, it's wrong. Without the negative, you're looking at something like the first number we did. Right? There you go. It's up here. All right, so going backwards, how do we do this? So we have 5.55 times 10 to the 6th. All right, here's how we do this. Write out your numbers. Take away the decimal place. So we have 5, 5, 5. Now, after this first digit, I'm going to draw a little line here. There should be 6 numbers. 1, 2, 3, 4, 5, 6. I'm gonna number them. We don't have anything, so we just put zeros there. And then you can put your commas in if you so choose. So there you go. Then you're done. Nice and simple. And the last but not least, we have 4.55 times 10 to the negative 7th. All right, so here's what we do here. Take this negative 7. I'm going to circle it. Get rid of the negative, right? So we have negative 7. Get rid of this negative. Subtract 1. You get 6. This number, 6, is how many zeros you're going to have. So you put your decimal place. 1, 2, 3, 4, 5, 6. Just gonna, and then you draw out these numbers here without any decimal place. 4, 5, 5. And you are done. Simple, just like that. right? So that is everything for this quiz. I'm gonna post this in. Um, this quiz is going to be very similar to what we just saw, what I just went over. All right, I'm telling you all that right now. I'm not going to be doing something like this for the test. I will not be doing a review like this. Um, we're going to be doing an in-class review. I will give you a study guide, but my problems are probably going to be a little bit different. So I don't, the quizzes, and I will say this right now, right? If you do watch this video, the quiz will be very, very similar to these practice problems. I'm okay with that. Tests are going to be a little bit extra. All right. So have a wonderful study session. I I tried. Yeah. So I don't think this is going to be too bad. We're going to go over one more topic before the test. We're going to probably play some Kahoot on Tuesday just to really review stuff. All right. So that's all for me.